Testing. Hello, class. I would like to review one example from section 5.2 that we covered last time. The reason I would like to review it is it'll show up in some of our work here today. This was in reference to interest compounded over a particular time period. Here we're compounded monthly, which means 12 times a year we would be calculating the interest, the monthly interest on this 5,000, and we would do that for 45 years. The formula that we had was this one here. It's already in your notes. We're just going to substitute in here. Our principal was 5,000. I was our annual rate divided by how many times it's compounded. It's compounded monthly, which is 12. So it's 0.06 divided by 12. Our N is the number of years times how many times it's compounded. Compounded 12 times 45 would give us that amount. When we ran it through our calculator, got this amount, took it times 5,000, and we ended up with $73,899.82. Again, notice we don't round off till the very end. We round off to the nearest cent. Our focus today is on annuities. This particular lesson is maybe the most challenging one here in chapter 5, but it's a super important lesson for you as individuals. Many of you are going to be starting in some type of vocation between the next 1 to 4 years. Frequently, whoever is employing you will give you a possible annuity to contribute toward. Our lesson today is on annuities, all right? Annuities, most of the time, are where we put in a certain amount of money from each paycheck. The previous lesson, we looked at lump sums. I invested 5,000 one time, or I might have invested 10,000 one time. An annuity is for most common people that don't have $10,000 to work with or to invest. But for most people, what they can do is they can take maybe $100 out of their paycheck every month and put that towards an annuity or towards retirement. Maybe they're going to take $200 out of every paycheck or whatever the situation might be. All of these refer to an annuity. Annuity is a sequence, means it happens regularly, of equal regular payments into an account, kind of like a retirement account. Each payment receives compound interest, which we looked at in the last section. Oftentimes, this is a monthly payment because most people get paid once a month into an investment or a savings account. So we're talking about something like every month, we take a certain amount off our paycheck and we put it into an account, which they call an annuity. The reason it's called an annuity is because we contribute to it every month or whatever time period we use. A simple annuity, which is the ones we're looking at today, the most common by far, is where the time each compound interest is calculated matches the time each payment is made. What do I mean by that? It means this: if we are going to have compound monthly interest, we would be making monthly payments into it. If I had compounded weekly, I would be asked to put in weekly payments. For most people, it's going to be compounded monthly and they're going to be putting in monthly contributions, a certain amount off each monthly paycheck. But for some people, if it's compounded quarterly, they might make quarterly payments. When they match up, quarterly payment, compounded quarterly, that's a match. Monthly payment, compounded monthly, that's a match. Those are referred to as simple annuities, by far the most common. This example is not super practical, but what it's designed to do is to help us understand how an annuity works, okay? So I'm going to look at an example of a very short-term annuity. Sometimes people call it a Christmas club, where people pay a certain amount every month to have saved up for the next Christmas expenses. So we're looking at basically putting an amount away every month so that when Christmas comes, we have a small savings account. That's basically how an annuity works. This becomes more of a savings account than trying to make use of the power of the annuity. The real power, this is key here for you as consumers, the real power in an annuity is setting it up for a long period of time. What do I mean by that? It means when you start working at age 22, you start putting a monthly amount away all the way up until you retire. Then you're going to notice the real power of what an annuity can do. The short-term annuities don't give you a lot of power, but it helps us understand how they work. So here's that example of a Christmas club. It's a very short-term annuity. Let's just imagine that I'm going to take $200 out of my paycheck at the beginning of every month that earns 6% compounded monthly. So I'm doing it every month and it's being compounded monthly. Hence, it's a simple annuity. How much would I have in the account by December 1? Okay, well, let's see what actually happens to that money. The future value of your August 1 payment, this is only the one you're making at August 1. You're actually going to make a payment September 1, October 1, and November 1. But just the August 1 payment, it's going to start generating a future value so that by December 1, we have to find out what it's going to be worth. So my principal will be the 200. The I will be 6% divided by 12. And it's going to be for 4 months. 6% divided by 12 for 4 months. Where did the 4 come from? Well, from August 1 is when we started. So by September 1, it's 1 month. October 1 is 2. November 1 is 3. December 1, when I take it out, I've got 4 months in there. That's why this payment of 200 is going to be earning interest for 4 months. It'll be worth $204.03 at the end of 4 months. Basically, we had earned $4.03 of interest. Not a huge amount, but I want you to understand how this works. This was the August 1 payment. It grew to 204. The September 1 payment, that's the amount we put in, $200 on September 1. It's not going to be earning interest for as many months. Notice, rather than 4 months, it's only going to earn interest for 3 months. Notice it doesn't get $4.03 interest, it only gets $3.02. On October 1, we'll make another payment. It will start generating its own future value. It'll earn interest basically of $2.01. November 1 is only going to be in there 1 month, from November 1 to December 1. It's in there for only 1 month. It earned only $1. Well, at the end, how much would we have by December 1? Well, we would add these all together, and the sum of all these would be our amount we have to spend on Christmas expenses. When we add them all up, we would have $8.10. What I want you to pick up from this, though, is the following. Each payment we put in started to calculate its own interest. Each payment had a different time period that it was calculating because the first payment has been in there the longest. The next payment, not as long. Next payment, less yet. The last payment, even less yet. Each payment had a different time period. That's what's really going on here. An annuity due is where each payment is due at the beginning of its time period. That would be the one we just did, was an annuity due. It's because we paid out the first payment on the first of the month. When you pay it out at the beginning of the time period, if it's compounded monthly and we paid it out the first of the month, that's an annuity due. Most people, however, get paid at the end of the month. So for most people, that payment coming out of their paycheck would be at the end of the time period, the end of the month. And that's why, because it's the more common one, that's referred to as the ordinary annuity. As I mentioned, the previous one was an annuity due. If I were to use the same conditions but make it an ordinary annuity, it would look like the following. This ordinary annuity got the payment August 31 rather than August 1 like the first one. Because it was at the end of August, it never earned any interest during the month of August. So from August 31 until right up to December 1 was basically only 3 months. That 3 changed. The previous example, it was in there 4 months. Because previously we put it in August 1. That was another full month of interest being earned. This one got put in at the end, an ordinary annuity, so that made it 1 less month. The second payment only was in there 2 months. The previous earlier example was 3 there. The October 31 is only in 1 month, and notice the last one really wasn't in there any month at all. We paid it November 30 and we're taking it out the next day. It had no chance to earn any interest. Notice this one is going to be a little bit less because basically each payment had 1 less month of interest. Last time I believe it was something like $810.06. This time it's $806.03. This next concept gets a little bit mathematical, but I want you to see a little bit where it came from. I'm not going to test you on where it came from, but at the end you will need to be able to have that formula down in your notes. We do not want to calculate long-term this month-by-month process where each one has a different amount of months, especially if you had to do that for a 20 or 30-year annuity. So we're looking at developing a formula. For our formula, we're going to be putting in n payments. That might be 12 times 40 years, might be 12 times 20 years. When the first payment will earn, our future value of the first payment will be the payment plus 1 plus I. Remember we had 1 less month? That's why this is an n minus 1. The second payment will have 1 less yet, so it'd be n minus 2, all the way on down till the last payment, you remember, was at 0. Then we needed to add up all of those amounts. When I add up all of those amounts, here was the first month and how much interest it made, second month, third month, fourth month, fifth month, maybe the 72nd month, whatever, until we get to the second to the last, which was to the first. And the last month, you recall, really was 1 plus I to the 0 power. But anything to the 0 is 1, which is why we just dropped it off, because 1 times the payment will just be the payment. Now we do some algebra. This is basically algebra 1, but it's going to look a little more complicated than that. We're going to take both sides of our equation. Notice right here I have an equation. So I'm going to multiply this side by 1 plus I. And I'm going to multiply all of this by 1 plus I. That's multiplied 1 plus I, not raised to the power. Notice this future value will be taken times 1 plus I. Now a little bit of a trickier spot. When I take this 1 plus I times the first one, these 1 plus i's are the same. We have to add the exponents. The exponent here was 1. 1 plus n minus 1, the 1's cancel and you just get n. When I take this times the second one, this 1 and minus 2 will sum up to be a negative 1. So I got n minus 1. Third one, n minus 2, until you get to the last one, payment times 1 plus I. Then I'm going to subtract the original. The original is all of this right up here. I just rewrote that. And I'm looking to subtract it. Why did I do that? Well, on the left side, it makes it look kind of complicated. It's this expression minus future value. That didn't do much for us. But look what happened on the right side. This first amount is identical to this one, which means it would cancel. The second amounts were identical. They would cancel. The third amounts aren't written, but they would have canceled. The fourth would have canceled. The fifth would have canceled. The 78th would have canceled. However many there are, this one would have canceled. And I would have been left with this first term right here, minus payment, which is at the end. Keep in mind now, I got rid of all of those terms in the middle. There might have been 3, but there might have been 300. They all subtracted out. Now my goal next is to solve for the future value. Solve for FV. So here, I'm going to start off with that exact same equation. Notice right there it is. I'm putting it right here. Haven't changed a thing. But what do we do next? We're going to factor out a future value. What do I mean by that? I'm going to take the future value out, and I'll be left with a 1 plus I minus a 1. That's factoring the FV out. I'm also going to do that to the right side, factor out a payment. So if I factor out a payment, I'm going to be left with 1 plus I to the nth minus 1. Those are equal now. I have that equality. Well, notice here my 1's cancel. So I have future value times I, which you see right there. This side I cannot cancel the 1's because it's this quantity raised to the nth. So I have to leave that one in place. I want to get future value by itself. So right at this point, I would divide everything by I. That would cancel those, giving me just future value equal to that expression. That gives me that particular one right there. I'm going to rewrite that now. And here's where I would like you to copy it down. The ordinary annuity formula, future value, that's FV right here, for an ordinary annuity with payment size. Payment size at PYMT is your monthly payment that you're taking out of your paycheck every time. The periodic rate is I. That's the same I that we've been working with. It's the interest rate divided by how many times it's compounded. And N is the exact same number we've been working with. So this formula is for our future value for an ordinary annuity. It's the most common one. If you need to pause to get that copy down, go ahead and do so. If you remember, we also had an annuity due. The annuity due meant every payment had one more month of interest. Rather than n times, it gets multiplied by 1 plus I one more time. So you'll notice the two formulas, the only difference is the annuity due has this expression right here, being multiplied. It's because we have one more additional month of interest. That refers to an annuity due. Again, if you need to pause for this, go ahead and pause, but make sure you have these two formulas copied down. And now we'll take a bunch of examples. Here's our first example. Find the future value of an ordinary annuity. Well, my formula, the future value is going to be my payment times 1 plus I to the nth power minus 1, all divided by I. You have that formula down in your notes. Let's find the future value in this particular case. My monthly payment is $100. The I, just like we did in the previous section, is going to be my interest rate divided by how many times it's compounded. It's monthly, so it's 8% divided by 12, 45 years, and it's going to be 12 times a year. I'm going to put that on there once right away. 45 times 12 turns out to be 540 times. Then I need to subtract the 1, and finally divided by that same I that I had up here. These two I's are exactly the same. 0.08 divided by 12. Again, there's a lot of different ways you can use this on your calculator. I am going to do the numerator here first. When I'm all done, I'm going to divide and use some parentheses on this one. That way I don't have to copy anything down. So here we go. I'm going to start with the inside, 0.08 divided by 12. Enter. That gives me that decimal. I then need to add 1. Enter. That gives me the whole parentheses. I got to raise it to the power 540. So exponent 540, enter. That gave me that whole expression. Then I need to subtract 1, enter. That gives me the whole brackets. That has to be taken times 100. Enter. That's the entire numerator now, okay? Now, that entire numerator needs to be divided by, this is what I'm going to be punching in. I'm going to have a beginning parentheses. I need to divide by this fraction, so I'm dividing by 0.08 divided by 12, closing parentheses, enter. That's what I'm going to punch at the end here. So I'm going to go divided by opening parentheses, 0.08 divided by 12, closing parentheses equals, and I must have done something wrong. I mispunched something. So let me start over here. Sorry about that. I'll see if I can go a little faster. I wasn't watching what I was punching. So plus 1 raised to the power 540 minus 1 times 100 divided by opening parentheses 0.08 divided by 12 closing parentheses, and I get my answer to be, in this case, 527,453.99. If you don't like this finish here, you can divide this separately and then do the numerator and have to re-punch in that number. I was trying to show it to you where you didn't have to punch in that long decimal number. Notice 45 years, 40 to 45 is likely the predicted amount of years you will work after college. They keep raising the retirement age. That's because people are living longer. For my age, full retirement is 67 and a half. Well, that would have been, in our case, about, let's see, from 22 to 67 would have been about 45 and a half years. You will likely be working even a little bit more than that. My point, though, is this. If you can take $100 out of your paycheck every month, 8% is actually a fairly common average for over 45 years. Some years you'll make more, some less, but that's pretty close to a common average. In 45 years, you would have over $500,000 for your retirement. Only giving up $100 a month, okay? Actually, how much would you have put in? Well, you would have put in $100 for 540 months. 540 times $100 gives you $54,000. You would have put in $54,000, but your money would have earned and grown to $527,000. Your money would have gained just under $500,000 interest. You didn't have to work for that. Your money worked by itself for that. That's what we call the real power of the annuity. Over a long period of time, it grows dramatically. That's why we are strongly encouraging everybody to do that. Take some amount of money out of your paycheck. A second example. This one is an annuity due. That formula was a little different. It was your payment. 1 plus I raised to the nth minus 1 all over I multiplied times one more month worth of interest. You would have substituted the same amount in, 100 for your payment, 1 plus the interest rate, 8%, divided by 12. 45 years was 540 like it was last time. Over the I, same I, 0.08 divided by 12. But then when you're all done, you would have multiplied by 1 plus 0.08 divided by 12. Calculate all of this, calculate all of that, multiply them together. And when you do that, I have that amount calculated here. Turns out to be $530,970.40. That's not much different. $530,000. Previous one was $527,000. And about an extra $3,000 because every payment got one more month's interest. The biggest thing though is look at the overall size. Over $500,000 for putting away $100 a month. Again, that $100 a month turned out to be only $54,000 over that 540 months, but it earned $500,000. That shows you the real power of the annuity. The government recognizes the power of an annuity. Our government wants us to take more responsibility for our retirement. Our government knows annuities make a lot of money for people if they can start young. That is why our government does this intentionally. They have made tax-deferred annuities. What does that mean? It means that $100 that you took out of your check is not going to be taxed when you take it out. They may tax it when you are retired and you start using it, but your tax rate at that point is much less, a lot of times down to 0. So your government is basically giving you a break by giving you a tax-deferred annuity. What do I mean by that? That $100 that you took out, or $150 or $200, they don't tax it, okay? It comes out what we call pre-tax, before the taxes take off your paycheck. They take that $100 and put it out and don't tax that part. That's tax deferred. Tax deferred annuity is an annuity where the money is automatically deducted from your paycheck. Here's the key: prior to taxes being taken out. Often, your employer will contribute to this by matching the amount or something similar. I'm going to take an example now here, and it's super important that you understand this example for your own financial benefit over the next 40 years. Okay, so here we go. Very, very important example. Imagine you just got out of college, you're age 22. You got a job at some company, and that company, your employer, offers a tax-deferred annuity where you have $150 taken out of your check every month, 10%, till you reach age 65. All right. Here's an important understanding, first concept. What does tax deferred benefit you? Watch once what happens. Because of your tax savings, your take-home check is not actually reduced $150. Your take-home check was actually only decreased to $110. It should be by $110. Why is that? Well, had you kept the $150, the taxes that would have come out of that would have been $40. So you would have only taken home $110 out of the $150. But yet you're going to now be able to, because it was tax deferred, you're not going to be putting $110 in every month. You're going to be putting in $150 every month. It actually only meant that your paycheck reduced to $110 because the extra $40 was going to go to the government. The government knows they're not getting that $40, but that's how much they want you to start investing for your retirement. They're giving you a break here, tax deferred, so that they're encouraging you, making it financially even better for you to start working toward an annuity. What will your tax deferred annuity, TDA, be worth when you reach age 65? Well, we got to find that out a moment. Let's do that. That tax deferred annuity will be future value, my monthly payment, again, times 1 plus I to the nth minus 1. This is an ordinary annuity. We didn't state that here, but if it's not specifically stated as an annuity due, it's always, you always think of it as an ordinary annuity divided by I. So my payment, notice I'm not going to be putting in 110. I'm putting in, before it was taxed, 150. I is my interest rate, 10%. It was monthly. So age 22 to 65, find that difference. Many of you can do that in your head, but if not, use your calculator. 43 years. And I'm going to have that every month, so it's going to be 43 times 12, which is 516. Let me just double check that number once. Yep, that's accurate. 516 minus 1, all divided by this same I, 0.1 divided by 12. If you run that through, again, I would go 0.1 divided by 12, enter, plus 1, enter, raised to the power 516, enter, subtract 1, enter, times 150, enter, to get that entire numerator. Then I'm going to go divided by opening parentheses, 0.1 divided by 12, closing parentheses, enter. And if I do that, turns out to be the following amount: 1,285,168.71. if you could deduct $150 a month, 10% is a good amount, but not impossible. Actually, over the last 50, 60 years, the average is probably closer to that than to 8. You would have 1.2, almost 1.3 million in there for your actual amount that you could use to retire off of. $150 a month. Now, watch some of these next things that I'm going to talk about. What will the portion of that future value, what portion of this $1,285,000 will be your actual contribution? Well, what did I actually contribute? I gave up. Now it looks like I should say 150, but I didn't actually lose that from my paycheck. I lost 110. So this was A. B, what portion did I give up? I gave up $110 a month that I would have otherwise gotten for 516 months. If you do that, 110 times 516 is 56,000. Double check that number once, 760. That is correct. What does that mean? It means I actually only gave up $56,760 over that 43 years. What did that actually do? That 56,000 grew into 1.2 million. That's the real power of the annuity. What portion of this future value, 1.2 million, will be the total interest in tax savings? Well, that's easy enough to find. I take that number and subtract what I contributed. What do I end up getting here? I end up getting the following: 1,228,408.71. This amount is pure interest and tax savings, because this is the amount the future value was worth. This is what I contributed. Everything else is money that was just being made for me. I didn't have to work for it. $1.228 million. Again, this is an example of the real power of the annuity. It is why the government wants you to do that. They're giving you a tax break to do it. Your employer is wanting you to do that. They want you to have a good retirement. So they're encouraging you to do it as well. Okay. If you had not used the tax deferred annuity and just got taxed on that 150, you would have got an extra 110. Let's say you put that 110 away for an annuity. What would have been its value? Well, that would have been basically, this is part D. That formula was previous section, if you remember. That formula, future value, it was equal to your principal, in this case, I'm sorry, payment, multiplied times 1 plus I to the nth minus 1. The payment would have been 110. It would have been everything else the same, 1 plus 0.10 divided by 12. It would have been the same, 516. And I would have not subtracted the 1. I'm sorry, that was the other formula. Okay? So when I calculated that out, it would have been still a significant amount. We still see the power of the annuity. Can't quite read that number. I think it's a 9. 942,000. By going with the tax deferred, it grew into 1.285 million. This was 942,000. This is still a nice chunk of change, but not the same as this one. This one is about $300,000 more. Okay? Don't miss letter E now, okay? Don't miss letter E. If your employer had matched your $150, a lot of employers do that. They want you to save for retirement. So to help encourage you to do that, they will match up to a certain amount. In this case, they're matching up to 150. Well, if they matched 150 and you put in 150, what would your thing be worth? Well, let's go back to part A. Part A, we found the worth if I just put in 150, but if my employer matches it, do you see that this number for payment would have been 300? It would have doubled this. If you double that, you get about 2,570,000, something like that, double that amount. Rather than 1.285 million, 2,000,570, something of that nature. Would have doubled the amount. Okay? Now, whenever, listen carefully to this, whenever your employer is going to match that amount up to a certain amount, do your best to save that amount. Sometimes employers will say something like this. They'll say, well, I'll match up to $100 a month. Okay, what does that mean? It means if you put away 30, they'll put away 30 for you. You would have 60 to put in every time. If you put away 40 every month, they'll match it at 40. And you would put in 80 every month for that payment. If you put in 100, they'll match it at 100, and you would put in 200 there. But notice this, if you put away 30, they matched it, but you left $70, they would have gone up to 100. You left $70, what we say, on the table, meaning the company keeps it. You don't get it. They pocket that. If you put in 40 every month, they'll match it to 40, but they will keep the extra 60. You don't get it. They pocket that. Here, they would pocket nothing because they were going to match up to 100 and you went to the 100. Whatever they're willing to do your best to get that much into the account because they will match up to that much. You will not leave money on the table or lose money in that regard. Okay? Super important that you catch on to that. Okay, another definition. A sinking fund is an annuity where you desire a specific amount after a certain time. Maybe again, it's for a grandchild's college or a daughter's wedding, etc. Basically, we're saying we want to lock in a particular future value. We want it to be worth a certain amount, and we've picked that amount. For example, imagine you want to set up a sinking fund for your new grandchild's college education. How much would you need to deduct from your monthly paycheck that would earn 8% to have $100,000 in there in 18 years? Again, assuming an ordinary annuity. Well, ordinary annuity, here's your formula again, same old, we've been using it all day. Notice though, how much would I need to deduct from my monthly paycheck? That means I don't know this payment amount. I do know the future value. I want it to grow up to 100,000. So I know the future value. I want to know how big a payment do I have to make each month so that in 18 years, it's worth 100,000. Well, 18 years is not a long time. It doesn't give the power of the annuity as much. It'll still show some, but it's not as dramatic as the previous example. I was 8% monthly, which means divided by 12. 18 years times 12 is N. So I got to take 18 times 12, 216 months that'll be, divided by the same I. I need to get all of these numbers into one number, then divide it into 100,000 to get my payment. So I'm going to do that from the inside out here again. It's going to be 0.08 divided by 12, enter, plus 1, enter, raised to the power 216, enter, subtract 1, enter. Now I'm going to divide it by this quantity. So I'm going to divide it by opening parentheses, 0.08 divided by 12, closing parentheses. And I get that number, 480,086,128. Decimal point is right here. 480. I got to divide that into 100,000. Either I can clear my calculator, go 100,000 divided by that, or I can punch that X to the -1 button. That reciprocates that number times 100,000. And I end up with my payment to be $208.30. What does that mean? I'm willing to deduct $208.30 every month from my paycheck. My grandchild could have 100,000 when they get to their 18th year or ready to start college. That's referred to as a sinking fund. I want it to be worth a certain amount. That's slightly different than this definition. This is our last concept for the day. The present value of an annuity is the one-time lump sum that could have been deposited at the beginning of an annuity's term that would yield the same amount. Okay? Yield the same amount the future value of the compound interest formula would have earned if you were to have contributed to the account on a regular basis. Well, exactly what does that mean? Let's take an example once. Imagine you're going to deduct $100 from your monthly paycheck for the next 40 years at 6%, using an ordinary annuity. Find the present value of that. I'm going to need just a little more space here. I'm just going to fold this up so I can slide this up a bit. Gives me just a little more space to work with here. Okay? What we're looking at is two concepts here. One concept is what will the future value of this ordinary annuity become? That's the formula we've been working with today. So let's find what this future value would have been worth after 40 years. It's our monthly payment times 1 plus I to the nth minus 1 divided by I. My monthly payment in this case was $100 a month. I is going to be 6%. It's monthly divided by 12, so 0.06 divided by 12. Raised 40 years times 12 is 480 for 480 months. The I is going to be the same, 6% divided by 12. When you calculate all of that, it turns out to be 199,149.07. Part of that was we didn't deduct a whole super large amount. And also it was only for 40 years rather than 45 or 47. Those last years is when you gain the most. Okay? So that's what the annuity would have been worth. They're wondering now, you remember, if I were to put in a lump sum, that formula, if you remember from way, way back, was future value. It was equal to our principal, one-time lump sum, 1 plus I raised to the nth. This was compound interest on a one-time amount. That one-time amount is referred to as your present value. I want this compound interest account to be worth $199,000 in 40 years. So I want my future value to be the $199,149.07. What would the one-time lump sum have to be for it to be that big after 40 years? Same 6% divided by 12, same in $480. We need to get that down into one number. So let's do that a moment on our calculator. Clear it off. I have 0.06 divided by 12. Enter. Plus 1. Enter. Raise it to the power 480. Enter. And I get that number to be 10.95745,367. I would need to divide that into 199,000. Or I can take and reciprocate that number and then multiply it times the 199,149.07. And it turns out to be 18,174.76. What does that mean? I could either take $100 every month and put it away, or I could take one-time donation of $18,174 and put it away for 40 years, either $100 a month for 40 years or this one-time payment for 40 years. Either way, I'll have the same amount at the end. This $18,000 is referred to as your present value of the annuity. Maybe you've seen an ad on television. I think one of the companies is J.G. Wentworth. And they will say, you have the right to have your money now. You are been blessed with some type of annuity. Somebody has set up an annuity for you where they're paying you a certain amount every month. And they're saying, we will give you a one-time lump sum payout. Well, that one-time lump sum payout is like the present value. Rather than getting paid $100 a month, which would eventually turn out to be that amount, they'll give you the one-time $18,000. So rather than getting $199,000 over 40 years, they'll give you the $18,000 right now. And then you're done. You don't get the rest of the money from there on. They usually would not give you exactly $18,000. They would bench that down a bit because they want to make some money on that transaction. So if it would have been worth $18,174, they may give you $17,000 rather than getting the $199,149. That's why usually those are a crock. If somebody's blessed you with an annuity that you're getting every month or some kind of rent per month off some property, keep taking it one shot at a time every month. Even if you put it away into an ordinary annuity, you'll end up with a whole lot more after the time. Okay, that is it for today. We are assigning 5.3 today. It is due 1 week from today. due 1 week from today. All right? Have a good rest of your day.